Hello guys, so in today's session we're going to talk about lead code problem 1254. So the problem statement states that given a 2D grid consisting of zeros and ones, an island is a four-directional connected group of zeros, and a closed island is an island totally surrounded by one. We need to return the number of closed island. So basically here we need to find closed island which consists of zeros that are surrounded by one from all of its four sides. O's lying on the boundary will not be considered as closed island because they are not converted by 4 from all of its four sides. So this problem is similar to one of the problems that we did earlier. It was an island problem. You can find that on my channel. So here we need to traverse the whole matrix given to us here, and we need to find O's. We would apply DFS on all of its four sides, and we would try to sync that region. I mean converting this O's into one. Let's check this thing out with an example. So this is an O, and this O is surrounded by one from all of its four sides. So this is a closed island. This bunch of O's are also surrounded by one from all of its four sides. So this is also a closed island. But let's see this O. This O is on the boundary, so it's not surrounded by one from all of its four sides. So this is not a closed island. And any region that is connected to this O would also be not a closed island. So let's say this one was an O. This one was also an O. So this would not be a closed island as it is connected by an O which is lying on the boundary, and that O is not surrounded by one from all of its four sides. Let's code this thing up to get a better idea. Okay. We would keep an answer variable. It would just calculate, or it would increment if we find a closed island, and in the end we would return this answer variable. Now we are traversing the whole matrix. Now if we find OO in this grid, we would apply DFS on that O. We would make a helper function to do our DFS. So what this helper function would take is, I explain the helper function in a minute. It would return a boolean variable. So if it's true, that means it's in closed island. So we just increment our answer variable and return that answer variable in the end. Now let's complete our helper method. So first of all, if any O is lying on the boundary, we will return false. Or if we are out of the boundary conditions, then also we will return false. So we are outside of our boundary conditions. We will simply return false. Or if we are lying on our boundary conditions, and if we encounter a 0 over there, we would return false, as this 0 would not be covered by 1 from all of its four sides, so it would not be a closed line. Otherwise, if we found a 1, we would return true. Otherwise, we are lying at a position where we found O and it's not on the boundary. So we would just simply convert this O into 1 and apply the same helper method on this O on all of its four directions. So this would do the trick. One thing to take care, let me show you in a minute. Let's see if it's working. Typo. Again. If it is equal to 1, we would return true. This thing. So it's working. Now one thing to take care about here is, let's say we use double end over here instead of a single end. It would pass the test cases, but it would fail. Yes, it would fail. Why this would fail? Let me explain. Oh. So what this thing does is, when we are applying the helper method, let's say we got a false, right? So we proved that this is not a closed island. But the thing is, we need to convert other O's that are converted to this O's. Means we found that this region is not a closed island. But we need to convert all the O's that are lying on this region to 1. So we don't consider them again. So that is why we need to run the other functions also. These other 3 functions. But the thing is, what this double end does is, when it encounters one false, it will not evaluate the other helper methods, and so we will not convert the other zeros into ones. So totally our function would fail in the end, and our answer would not be correct. So this is called short circuiting. So it is always better to use a single end in this kind of problems instead of a double end. If situation arise, we can use a double end also, but basically it helps to improve our time complexity, because we are not evaluating the other helper methods. So yes, you need to take care about the situation over here too. That's it from my side. Thank you.